Hi everyone, I am Saurabh Kumar Singh and today I'm going to talk about Unicast routing techniques for mobile ad hoc networks. So let's begin. Abstract. A mobile ad hoc network, which is also known as MANET, is an autonomous system of functionally equivalent mobile nodes which must be able to communicate while moving without any kind of void infrastructure. At this end, mobile nodes must cooperate to provide the routing service. Routing in mobile environments is challenging due to the constraints existing on the resources like transmission bandwidth, CPU time, and battery power, and the required ability for the protocol to effectively track topological changes. This paper discusses the issue of routing in mobile ad hoc network by focusing on the main solution proposed in the literature to cope with mobility. The paper surveys the techniques adopted for the case of unicast routing, that is, when it is required to send a packet from a source node to a destination node, by illustrating how they are introduced into the main representative protocols. Introduction. The term MANET refers to a set of wireless mobile nodes that can communicate and move at the same time. No fixed infrastructures are required to allow such communications. Rather, all nodes cooperate in the task of routing packets to destination nodes. This is required since each node of the network is able to communicate only with those nodes located within its transmission radius R, while a source node S and a destination node D of the MANET can be located at the distance much higher than R. When S wants to send a packet to D, the packets have to cross many intermediate nodes, and for this reason, MANETs belongs to the class of the multi-hop wireless networks. Proactive protocols. The advantage of these protocols is that a path to the destination is immediately available, so that no delay is experienced when an application needs to send packets. In some cases, this can be useful as for interactive applications. The main mechanism adopted in proactive protocols are the following. The first one is to increase the amount of topology information stored at each node to avoid loops and speed up protocol convergence. To vary dynamically the size of route updates and or the updates frequency to optimize flooding. To combine DV and LS features. Tailoring distance vector protocols DSDV. The destination sequence distance vector DSDV protocol is one of the first attempts to customize the classical DVF protocol. The key elements of DSDV are an aging mechanism based on monotonically increasing sequence numbers that indicates the freshness of the route and which is used to avoid routing loops and the count to infinity problem. B. The use full route updates sent periodically. Every update interval or incremental route update sent on topological charges. C. The delay of route updates for routes that are likely to be unstable, that is, those for which a new update is on the way towards a node. Reactive protocols. A different approach for routing in mobile environments is routing on demand. The approach is characterized by elimination of the conventional routing tables at nodes and consequently the need of their updates to track changes in the network topology. On-demand routing protocols calculate a path before data transmission. If data traffic is not generated by nodes, then the routing activity is totally absent. For such a reason, they are also called reactive protocols. A reactive protocol is characterized by following procedures used to manage paths. The first one is path discovery, second one is path maintenance, third one is path deletion, the fourth one is data forwarding is accomplished according to two main techniques, source routing, hop by hop. Position added protocols LAR. Renewability in the location added routing protocols LAR is the estimation of the position of the destination node used to increase the efficiency of the discovery procedure. Only a subset of nodes are queried during the discovery phase, specifically the ones in the so-called request zone nearby the estimate. LAR uses standard forwarding as last resort when no stations are available. The position can be obtained, for example, from the global position system GPS. The request zone is calculated from the expected zone, which is defined as a zone where the destination node D would be located from the viewpoint of the source node S at the current time T1. Given that S known is platform at some time or T0 in the past and average velocity. Protocol performance analysis. A protocol performance analysis aims to measure two complementary aspects. The first one is how efficiently the routing services is provided with respect to a given set of cost index, example, bandwidth, battery energy consumption, CPU cycles. The second aspect concerns application-oriented metrics, that is, the performance seen externally by an application in using the protocol. To evaluate these two aspects, protocol complexity analysis and protocol simulation have been used. The aim of the complexity analysis is to measure at a simplified and abstract setting the resources required the protocol in performing a single protocol operation. For example, the reaction to a link breakage. Conclusions. Many protocols have been proposed in the literature to provide routing in a mobile environment. In this paper, we have illustrated the main techniques proposed to deal with mobility in the case of unicast flat routing protocols. The experience gained in wired networks have influenced the design of mobile ad hoc routing protocols in many ways. However, wireless mobile networks introduce several concerns that make the routing issue completely different from one provided for the fixed counterpart. For example, the limitation on the battery lifetime and transmission bandwidth, as well as the notion of route stability, lead to a new notion of base route. Also, fairness is an important property of a protocol since using always the same route result in battery drain out of the same mobiles. So now that's all from this video. Hopefully it will be a little bit informative. Thank you.